Hi guys, so here's your lesson for Wednesday, April 15th. Okay, it's the last day of this unit. And today we're just going to look a little bit closer at transformations and absolute value functions, which we learned about on Monday. Okay, so just remember the absolute value of anything, okay, is always going to be positive. Same thing, okay? So when we look at some problems, number one, the graph below represents f of x. Okay, which graph best represents the absolute value of f of x? So remember, anything that we have, okay, inside the bars is always going to be positive once we take the bars away. So we have to think about that in terms of the graph we're looking at, okay? So if we look, we want the x values to be all positive, which means that we can't have anything down here, right? These are all the negative x values. We only want the values that are above the x-axis, because those are the positive ones. So any of these, if we look up, this looks okay, right? There's no negative x values. Not okay. Not okay, the line goes below the line. Not okay, the line goes below the line. So really, our only choice here, oops. I meant to not cross that one out, I meant to cross this one out. Our only choice is here because there's no x values below the line. No negative x values. Number two, which is the graph of y equals the absolute value of x plus 2? Well, this is where GeoGebra comes into handy, guys. Just type it into the graph and pick which one matches. So let's delete this. I'll put in our new function, f of x equals the absolute value of x plus 2. And there it is. So I go back to my choices, and whichever one looks like that, starting on the y equals 2. Oh, okay. Must be this one. Not difficult. 3. Which graph represents the equation y equals x minus 2 inside the absolute value bars? Well, let's look. Let's go back. F of x equals x minus 2. Oops, I forgot my absolute value bars. X minus 2. Enter. Okay, so let's find one that looks just like that. That's not it. That's not it. Not it. Oh, it must be that one. Okay, notice you have 0, 2, and you have 2, 0. And that matches up nicely to our graph. Okay. Problem 4. What is the minimum value of the function y equals the absolute value of x plus 3 minus 2? Okay, so the minimum value. Let's go back and let's type in our equation. Y equals the absolute value of x plus 3 minus 2. Enter. So the minimum value is the lowest value that you're going to see on this page. Okay? The minimum value here is, if we look, x is negative 2 is the minimum value. Whatever, okay, our lowest x value is. There's nothing smaller than negative 2 on this graph. So I go back and I choose negative 2. Last few problems here. Question 5. Which equation represents the function below in the accompanying diagram? Okay, so this seems like it could get a little bit trickier, right? The best option for you is to type each one of these equations into GeoGebra and see which one matches the graph it's giving you here. So I'm going to go back and I'm going to type in my first multiple choice, f of x equals the absolute value of x plus 1. Well, that kind of looks like it, right? Is that it? That is actually it, but let's just type in another one just to make sure. See the difference here. That would be minus 1. And then if we did the other two, let's duplicate. X plus 1. No, that's definitely not it. And the last one here, we could have x minus 1. Now that's not it either. So the only one it could be is that first one that we had, choice 1. Choice 1. Okay, you notice how they're both on 0, 1, and they're both the same equation. Number 6. The table of values below can be modeled by which equation? Okay, so again, same style that we just did in number 5. I'm going to type each one of these into GeoGebra and see which table of values matches our table of values here. So the first one, f of x equals the absolute value of x plus 3. Enter. Okay, I'm going to go to my table of values, and if we look at our x values here, we start at -2 and we end at 2. So we're going to make sure our table reflects that. Starting at -2, ending at 2. Perfect. Okay. Alright, so when we look at our table of values here, you should also be looking at the table of values from the question. You have -2, 1. -1, 2. Is that the same here? -2, 1. Nope, not it. This one is no good. So let's go back and type in equation 2. F of x equals the absolute value of x plus 3. Enter. Okay, same thing. We're going to look at our table of values from -2 to 2. So we have -2, 5, -1, 4, 0, 3, -2, 5, -1, 4, 0, 3, and the last two, 1, 4, 2, 5, 1, 4, 2, 5. Identical. 1, 4, 2, 5. This is my choice. Choice 2. Okay, if you typed in choice 3 and 4, it wouldn't work either. Actually, if you go back and you type in, notice how it has an f of y, not an f of x. So I want to just show you what's going to happen when if you put something like that into the calculator. F of y equals the absolute value of y plus 3. It's not even going to give you a function because you can't have y inside the parentheses like that. It does not make sense. Okay, last problem here. On the set of axes below, graph y equals 2 times the absolute value of x plus 3 in the interval -7, x is between -7 and 1. So automatically we know that x is in between -7 and 1. So here's x equals -7, here's x equals 1. So I don't need to go any further on the graph than these two x values. So I shouldn't have anything outside of those bars, those yellow lines. The whole entire graph is going to be inside those lines, okay, just based on the interval. So now let's go to GeoGebra and let's type in your equation. Y equals 2 times the absolute value of x plus 3. Okay, so now let's go to our table of values, or you can just look at the graph. Look at the vertex, the very starting point here. We have 0, -3. So I'm going to put a dot on 0, -3. And then I'm going to go to another nice point, which is -2, 2. -2, 2. How about -1, 4 and 0, 6. -1, 4, 0, 6. And you can kind of see the pattern, right? We're moving up 2 over 1. So if you follow this for the rest of the graph here, you can go back as many times as you want to copy points, but this is what it's going to look like. No arrows on the end. No arrows because we have an interval here. Okay, it's only between -1 or -7 and 1. Okay. All right, guys. That's it for today. That's it for our unit. Please take a look at the assignment for today and let me know if you need any help.